Hi Twitch, and welcome back to coverage from the AWS Summit here in New York. We're live on twitch.tv/AWS all day with content from this AWS developer event here in the US. And I'm joined for this next segment by another expert guest. And obviously the first thing I'm going to do is ask my expert guest to introduce themselves, talk a little bit about who they are and which part of Amazon Web Services they work in. So go ahead.
Sure, thanks. My name is Richard Elberger. I'm a partner solutions architect in IoT, and my day job is that I work with all of our hardware partners to ensure that our customers have a great experience building solutions on top of AWS.
Now, you mentioned a key phrase there, which is IoT, and just bear in mind that a lot of the viewers that are likely to be watching this stream on Twitch may not be familiar with what that means. So I think the collection of, I won't say the word, items that we have in front of us on the desk here might give a clue to what we're talking about, but I think it would be great for you to just to start by introducing to the audience what is IoT.
Right, thanks, Ian. So IoT means Internet of Things, and effectively what it entails is connecting everything from very small devices to larger devices through the internet in a most times mobility way.
And I guess you've got something to show us with this setup that you've brought here today. So what is it that you're going to be demonstrating for us in this next segment?
Yeah, so what I'll be demonstrating a little bit later on is how we can connect things in your home with very small microcontrollers using Amazon Alexa.
Okay, great. I think you've got a few slides to talk us through, so do you want to kick off with that? Maybe we can have the presentation laptop on the stream, please.
So one of the themes that I try to carry through when I'm working, when I'm talking with customers in more fun way, even partners, is getting connected, things in your home. Because what you're seeing out in the ecosystem today, in the Internet of Things, is people selling new devices, right?
Yep.
But many times what people have are older devices that they want to connect to the internet and connect through facilities such as the Echo device, right? So things like a lamp uses an on-off switch, and a radio will use a tuner, which is sometimes facilitated, many times facilitated by a potentiometer, right? If we do this in an electronics way, we'd use a digital potentiometer. But really what's happening between the user and the device is a bunch of magic up in the cloud, up in the AWS Cloud, right? So what you'll do in working with Alexa or with the Echo Dot is that you'll say, for example, Alexa, turn on my kitchen light. And this sends a message up into the AWS Cloud and does something magical. The light turns on, sends a message back to Alexa, and then you get notified that something happened cool, right?
Yeah.
But let's go down a little bit deeper. Actually, that magic is facilitated by a thing called an Alexa skill. And an Alexa skill really simplifies the way that our customers and partners build solution for folks worldwide buying consumer products. So they'll build skills to do certain word phrasing and that sort of thing, then work with the AWS Cloud, such as serverless solutions like AWS Lambda, and then that will go and facilitate all this talking to the device that's living in your home, going back through AWS, back through the skill. Now, what Alexa has done is actually simplified this process a lot for those folks building solutions for the smart home. So we actually have the Alexa Smart Home skill now, which enables a certain number of phrases so you can focus more on the business logic that you want to implement to carry out the actions on these devices.
So how would you go about building something like this if you were a developer that had some software engineering skills but didn't have familiarity with some of these terms or technologies that you've talked about, Alexa skills, some of these AWS services like Lambda? How would I, as a developer with software engineering skills but not domain-specific skills, get started building something like this?
Sure, so there's a few different domains that you would have to learn over time. But really, you can start at the Alexa site itself. It has a lot of great entry-level documentation to lead you through the development process. And the same thing for all the AWS Cloud aspects as well, whether it be Lambda or Cognito that you really need to use in order to make the solution happen.
Okay, great, great. So can you talk us through the setup that we have here and how you're going to show us what you've built here?
Yeah, sure. So what I've built here is a very, very simple demonstration of using the Echo Dot device and communicating to Alexa up in the cloud, which then, in turn, executes a Lambda function, which then talks to AWS IoT, which is our IoT service up in the AWS Cloud. And it changes a bit of functionality up there called device shadow. And what the device shadow is a virtual representation of your physical device, how it actually works. So when I change something in device shadow, this hardware here knows that that happens, right? So what I can do is I can go ahead and hopefully it all magically works due to network, but I can say, Alexa, turn on the kitchen light. And the LED may not be too bright for our viewers online, but it turns the light on and it actually fed the information back to Alexa, and I can do the same thing back to the dot device, and I can do the same thing to turn it off. Alexa, turn off the kitchen light. Now, what's really cool about Alexa Smart Home is that it's not just about turning on and off switches and turning and that sort of thing, but it can do thermostats, and it can do entertainment devices, and that sort of thing. So.
Okay, great. I actually have some stuff in my home which is set up using the smart home skill, but it's obviously from, well, not obviously, it's from commercial manufacturers. So
yeah,
things like Wi-Fi light bulbs and smart switches that you might use to control powered equipment of the type that you're talking about. How would a manufacturer like that build a product like that using some of these services that you've talked about? Because this is obviously not something that you could ship out to a customer. It's functional, but it's not got industrial design characteristics. So how would a manufacturer of electrical products or consumer electronics products go about integrating this kind of technologies together to build a physical product that would be sold through retail?
Right, so there's two real aspects that you have to implement at that point. You have the firmware that's going onto the physical device, and you'll be actually designing your own PCB, your own enclosure, maybe working with an original device manufacturer to make that side happen. Yep. That's going to have all the code that's going to work with the AWS Cloud. But there's another part that you have to implement as well, which is all the cloud parts. So there you'll have to implement two key services, well, three actually, AWS IoT, which communicates with the device through a device shadow, AWS Lambda, which is the interface to the Alexa skill itself, and then the Alexa skill. But there's not really much for the Alexa skill that you have to implement. Because it's a service that's been implemented as an abstraction layer over the Alexa skill dev kit, you just have to enter a few fields for your Cognito pointer and your Lambda pointer, and you're basically ready.
So you mentioned Cognito there, which is probably a service that watchers on the stream are not familiar with. What is Cognito?
Yeah, so Cognito is mobility, authentication and authorization service that we have in the AWS Cloud. And you can use that with mobile and other clients, usually for mobile. But in this particular case, what we're using it for is OAuth 2, authentication. So when you actually go and enable your skill for your Alexa Smart Home, like that device manufacturer, you actually have to link your account to create that security linkage between Alexa and the device manufacturer. So you have to implement OAuth 2 when you actually go and authenticate. It's going to redirect you to that OAuth 2 username and password page that you typically get out of Cognito.
Okay, there's a question here from the stream from, I think it's Fluff TV. He says, why exactly do you need the IoT service? What is it that the AWS IoT service does that you cannot do solely with AWS Lambda and Alexa skills? So what is AWS IoT, and what exactly does that provide to a device manufacturer or a hobbyist developer that is building technology like this?
Yeah, AWS IoT is a managed service up in the AWS Cloud, and it's composed of a few basic components. The first is a secure MQTT server. So MQTT is a pretty standard technology that you use, or protocol that you use today to communicate between IoT devices, right? And that messaging—
a message passing
that's right,
service, right? Yeah.
That's right.
Okay.
And another component of that is Rules Engine. And what Rules Engine does is listens to those topics within the MQTT server and actually proxies those to other services within AWS. And then the third component of that is the device shadow. which I've been talking about throughout the talk.
Yeah, so tell me a little bit more about that. You've mentioned it several times, but you haven't given a lot of detail about what it is.
Yeah.
So understand the MQTT service is the message passing. This rules engine, you said that's how you communicate with other services from those messages, right? But what is the shadow? What functionality does that provide?
That's great. It's just like the awesome killer feature that's coming out of AWS IoT, because what you're able to do with that construct is use command and control functionality. So it's very, very difficult in distributed systems to be able to tell something to do a thing and then to get a response back in a very methodical way. And what you're able to do with the device shadow is tell the device to do something, which is called a desired state, so it's a stateful document. And then that enables the device to actually send another message back to AWS IoT Core that is the reported state. Now, when the desired state and the reported state differs, you get a delta. And that delta topic within the device shadow is the one that your device is subscribing to. Okay. Because you really, really just care about when your device needs to do something.
Just changes, right?
That's right.
Right, okay, okay. So, just explain to me why that's such a difficult problem to solve. Seems pretty simple to me. I have loads of devices in my house that are connected via Wi-Fi. I have cellular devices like my wife's Mini, for example, which communicates with the manufacturer using 3 or 4G, I guess, for the transport. So what exactly is difficult about reliably sending messages over those networks? Are those networks not reliable?
Yeah, so another great thing about the device shadow is that it is really a small, quick and easy document storage mechanism, right? And what you could imagine with IoT is that you're dealing with networks, sometimes not very stable networks, and your device can become disconnected. Now, when you're working with an MQTT broker, you'll only receive a message when you've been subscribed to that particular topic, to the Delta topic. But what happens if your device becomes disconnected and your session breaks? That message comes through and you don't get the message.
Right.
Well, when the device comes back up, when the network becomes reconnected, what you're able to do is go and fetch the entire document from AWS IoT Core, which enables you to understand what the device state should be.
So the device can kind of say to the service, tell me how I should look right now.
That's
and it gets a complete state download, and then it can synchronize with that state.
That's right.
Okay, cool. So we're live from the AWS Summit here in New York today. AWS is the cloud computing unit within Amazon.com. So we provide services that developers can use to build applications, run their applications in what's become known as the cloud. We're focusing here on Internet of Things with a prototype service for voice control of a prototype household device represented by this simple board. So we're looking for questions from the stream. If you have any questions that you want to ask our expert on the topic of IoT, please submit those using Twitch chat and I'll get them over to him. And I want to ask you something about precisely what this is. So tell me a little bit more about what is running on this hardware package that you have here. Well, first of all, tell me what is the hardware package, and then secondly, tell me what's running on there.
So like I said, I'm a partner solutions architect in IoT, right? So one of the great partners I get to work with is Texas Instruments. This particular board right here is Texas Instruments CC3220SF, which is one of the boards that was qualified for Amazon FreeRTOS launch that we launched at reInvent last year.
What is that? What is FreeRTOS?
Yeah, so FreeRTOS, well, Amazon FreeRTOS is effectively a distribution built on top of FreeRTOS, which is a real-time operating system that's been in existence for about 15 years, right? So what we kept on hearing from customers over and over again is the same thing, the same challenges they were facing in developing firmware for going to market. The same heavy lifting that they were doing every single time. If you know one thing that we want to do at AWS is that we want to remove that undifferentiated heavy lifting that our customers have to do to get to market, right? To actually release solutions. So what we're running on here right now is Amazon FreeRTOS using Wi-Fi connectivity. So with Amazon FreeRTOS, you have a couple of choices right now, Ethernet connectivity or Wi-Fi connectivity. using the MQTT libraries that are in there, and also the built-in SSL libraries as well.
So what is the programming model for creating software to run on this device? What do I actually write and deploy onto that device, and how do I go about deploying down onto it? Is it JavaScript? Is it Python? Is it something else? How do I actually construct my code and flash it or push it down onto that device for it to operate?
Yeah, so this is actually running on very, very constrained devices, microcontrollers. This one is actually, may be sounding like a little academic, but it's a Cortex forum, which is very, very small, right? So in that particular case, we actually use the C programming language to implement all that code.
Okay.
In this particular case, we're also using the Texas Instruments IDE called CC Studio, which has all the tools and capabilities built in that you need to write the firmware and actually get it staged for production.
So there's a question from the stream, if I can just find this here, from, let me get this right, Tubadak, maybe? T-U-B-A-D-C. He's asking, why do we not use another AWS service like SQS for messaging? And that's another message interchange service. So what are the distinct characteristics that set MQTT apart from a protocol or service like SQS? Because that's not the protocol, right? It's something else. So
that's good. That's a great question. So the thing about MQTT is that it's a lightweight protocol, socket-based protocol, right? And it was built to be lightweight because many times we're working with these constrained devices. When we're working with SQS, we're working on web services capacity, right?
Yep.
So in that case, you would need to have not only an HTTP client on the small constrained device, but an HTTP client that's capable of doing secure sockets.
Right, and that's a big computational task for a tiny little processor like that, right? Yeah, okay.
That's absolutely right.
Great, so I think we're getting close to wrap-up time. Let's just check if we've got any other questions from the stream. Oh, we do. This is from somebody that obviously knows a little bit about AWS, and this is going to lead us into a different area. So,
okay.
It's from Tom G. Poole. He says, can you describe a real-world use case for another AWS service called Greengrass? So maybe you can quickly introduce, for the benefit of those people that aren't as expert as Tom, what Greengrass is, and talk a little bit more about how customers might use that specific service.
That's right. So I have a slide here that kind of leads us through that, and I'll just do it quickly, where you have AWS IoT, and through Wi-Fi you can connect several devices. And here's the service that our customer just mentioned before is AWS Greengrass.
Yep.
And what AWS Greengrass does is it takes a lot of the services that we have up in the cloud, and we brought that down to the edge. So like I mentioned before with device shadows, where you're able to work in an offline capacity, we can actually do this with higher compute devices. So what we've done is brought the MQTT server and device shadows from AWS IoT Core, AWS Lambda from Lambda, of course, and also all the security wrapped in. We even have a security construct called Token Exchange Service, which enables you to work with any service in AWS in a secure way.
Okay, so that's for a more powerful edge device than this particular device that you've got here, then that's what you're saying,
That's right.
Okay, and what about use cases for Greengrass? Can you talk about any customers that you've worked with or that you're aware of more broadly within AWS that are using Amazon Greengrass today to build, or AWS Greengrass today to build these kinds of services?
Sure, so we've had a lot of customers actually have public cases over the last year about AWS Greengrass, but some really cool ones that have surfaced have to do with aggregating data and doing analytics on the edge. So when you look at things like, for example, Pentair, doing those air filtering at the edge and trying to figure out analytically what they could do better, right? Just a few months ago, we released the ML at Edge, which allows you to actually build models up in the AWS Cloud, these analytics models up in the cloud, and actually get those down to the edge so you can run those
machine learning inference at the edge of the network.
That's right. So that way you can get answers a lot faster.
Great. Excellent. So we're almost out of time for this segment. I want to thank the viewers on Twitch for the really excellent questions that we had in the course of that segment. Obviously some users on the stream of AWS IoT, or users on the stream with an interest in AWS IoT, and it's great to see you watching us here live from the AWS Summit in New York. We will be back very soon after this short break, and thank you, Richard, for joining us on AWS here on Twitch from the AWS Summit. Thank you.